So operators, types, and literals. So let's first talk about a few literals. So a string. Well, first of all, what is a literal? A literal is used whenever you want to type the value of something directly into your code rather than calculating it. That's fairly straightforward. A string is enclosed in quotation marks. So that's the syntax. Quotation mark is used to indicate a string literal. The first quotation mark starts it, the second quotation mark ends it, and all the characters in between then become a string. A double. So if you want to type a value that is going to be a double, something with a decimal point, you just type the decimal point. So if I want it to be stored as a number with a decimal point, with a fractional part, I need to put 0.0, and that is sometimes important to actually put the 0.0 in there. Now a float, remember the difference between a float and a double is that a float is stored with 32 bits and a double is stored with 64, so there will be less rounding error with a double. But some libraries that you will use will expect the input to be a float. And if that's the case and you're typing in a literal, you need to type it as a float, otherwise the method that they write won't work. So to type a float literal, you have to put an F after it. So this 3 without the F would have been an int. If I had typed 3.0 without an F, it would be double. If I wanted to type 3.0F, I could. But an F at the end indicates that the number is a float, and this is the number 3 stored in 32 bits with a possible decimal point. Int. So that's your whole numbers. You can just type the number as you're used to in base 10. So like if I wanted to type the number 254 into my code, I just type in 254. But there is another representation. We call it hex. And so what we're accustomed to is base 10, the symbols 0 through 9. There are 10 of them. 0 is the first symbol. 1 through 9 are the other 9 symbols. So there are 10 symbols. But computers understand another representation called hex. And you will often see hex representations of numbers when we're working with color. And if you want to type in a literal that is using the hex representation of an int, you use a number 0, the letter X, and then the numbers hex representation. The difference between hex and base 10 is that instead of 10 symbols, we've got 16 for each digit. So this is a number. This is actually the same number. It's 254. The first digit is the ones place, and the next digit is the 16s place instead of a ones place and a tens place and a hundreds place. And the symbols are 0 through 9, A, B, C, D, E, F. So an F has the value of 15, then E has a value of 14, and so 15 times 16 plus 14 should give you 254. So if you want to type an int in hex representation, you type the 0 and X and then the number. A char, a single character. To type in a character literal, you use the apostrophes. So if I want to type the character A into my code and store it in a variable of type char, I put apostrophes around the A. Now there's one extra little note that's important with respect to strings and chars, and that's that you have some special characters. Notice in this string I have quotation marks. You might ask, what if I want a string with a quotation mark somewhere inside of it? Well, Java has a thing called the escape character. And essentially what the escape character says is, hey, interpret the character after me different than you normally would. And the escape character in Java is the backslash. So there are several different escape characters that are commonly used. This is not an exhaustive list, but these are the most common. So I'll start at the bottom. A backslash apostrophe is an apostrophe. Now if I typed an apostrophe in a string, that would be just fine. If I typed in a backslash apostrophe, I get exactly the same result. So why do we have a backslash apostrophe? Simple. It's if we want a character that is holding an apostrophe. If the first apostrophe opens the character and the second apostrophe closes it, what if the thing in the middle is an apostrophe? It's going to see the apostrophe in the middle as the closed, and it'll give you an error when it sees the third one. So if you want a character that is an apostrophe, you need a backslash apostrophe. If you want a quotation mark inside of a string, you need a backslash quotation mark. Now since the backslash now has special meaning, if you want a backslash, you need a backslash. Backslash, backslash. This two backslashes will be interpreted as a single backslash character, either in a string or character literal. Now there are some keys that are called your white space keys. Now hitting the space bar, space bars, tabs, and enters are all white space keys. If you hit the space bar, it just puts a space there, and you can do that in a string literal. Tabs are more difficult. New lines are a lot more difficult because we often want to break up our code. So the way that you get a tab in a string literal or a character literal is a backslash T. And the way that you'd get a new line, or the enter key, is often referred in programming as a new line, a backslash N. And so that's pretty much it for literals. If you understand these rules, you'll know 95% of what you would ever need to know to be able to type all the literals you need to type in your code. So let's get into a few of the dirty details of operators. First of all, the assignment operator can do some conversions. So most of the time, if you have a variable that's of a certain type on the left of the equal sign and a variable that's on the right of the equal sign, or some value, the values have got to be of the same type. So, but sometimes they don't actually have to be. If I have a 5 here, this is a literal 5, and I have on the left-hand side of the equals a variable of type double. Well, this is an int, that's a double. This int will be converted to a double so that it can be assigned to the x. And that can be, well, convenient, but there are times when it can be a little bit confusing, because if I have an int and a double, it won't convert the double to an int without a cast. And I think we've talked about casting. If I wanted to convert that double to an int, I would have to put round brackets around it and type int. Now, I've put a literal here, but this could very well be a variable that's holding a double value. The reason that Java is willing to convert ints to doubles, but not doubles to ints, is because int to double is what's referred to as a widening conversion. And a double to an int is referred to as a narrowing conversion. You see, when you convert a double, like 5.2, to an int, it cannot hold the 0.2. If I have an int value on the right and I put it into a variable of type double, well, that's a widening conversion, and it's going to be able to hold it. It's going to be able to do the conversion without any loss of information. But if I try to convert a double to an int, it's a narrowing conversion. There's some loss of information. It chops off everything past the decimal. And Java will not do a narrowing conversion. It will not automatically lose information unless you put a cast in front of it and tell it that you're really confident that that information is not important and it's okay to throw it away. So that's a little bit of widening to narrowing conversions. Also, if you convert a float to an int, that's also a narrowing conversion. So just the general rule, Java will not throw information away, and it will force you to put in a cast if it's a narrowing conversion. And then there are two types of arithmetic. So we've got addition, subtraction, multiplication, and division. There is integer arithmetic, and then there's double arithmetic. And I think we've talked about it, and some of you have got it, but some of you still don't. If I have 3 divided by 2, both of those numbers are integers. Java will do integer arithmetic. If both of the numbers involved in arithmetic are integers, it will do the calculation and throw away the remainder. So 3 divided by 2 is 1 with a remainder of 1. It will assign the 1 to x and throw away the remainder of 1. So it does integer arithmetic if both are integers. This is a tricky little statement. I have 3 divided by 2 and I assign it to a double because I want 3.5. Well, the challenge here is that 3 divided by 2, both are integers. It does the integer division, it throws away the remainder, and then it does the conversion to a double. And it has to do with the order in which things happen. The 3 and the 2, the division happens first. It's integer division, so you lose your information before it is converted. So if I cast one of those values to a double, or if I just type in a double literal, then I get double arithmetic, which gives me the decimal value. So 3.0 divided by 2 is 1.5. Even though one of those values is an int, if either of them has a decimal point, it will not do integer division. It will do double division and stick it in a double variable. And so all math, really, addition, subtraction, multiplication, and division, has two types, integer and double. And doubles are treated differently. If either of the values is a double, it'll do the double arithmetic. It is sort of important to note that the only time you have the issue with a remainder is with division. But under the hood, even with the others, addition, subtraction, and multiplication, there are some really subtle differences that generally don't come into play, but occasionally do. Division is the one that you mainly have to worry about when you're thinking integer versus double arithmetic. And then with addition, there's another little special detail, is when you're adding something to a string. So the plus symbol is used for addition, but it's also used for concatenation. And if you have something that is a string added to anything else, it will convert that anything else to a string and then append the two together. Now I put an empty string because this is often a neat little trick that is used to convert something to a string so that you can print its value out conveniently. Or display it on the screen or something like that. So this is a double quote, it's an empty string. You add it to a 5, it converts the 5 to a string, appends the two together, X now holds the string 5. The relational operators. So the relational operators work best with numbers. You're comparing whether one is greater than or less than the other. You've got a number on the left, you've got a number on the right, and the entire expression evaluates to either true or false. So the types of the operands for relational operators are typically numeric, either ints, floats, or doubles. And it doesn't matter if the thing on the left is a double and the thing on the right is an int. It does what one would normally expect it to do. You can sometimes use the relational operators on characters, but you have to be careful because you don't always get the results you would expect. It's especially unpredictable if one of the characters is capital and the other one is lowercase. So I would tend to use this only with numeric values to evaluate which of the numbers is bigger and which one is smaller. The conditional operators, ands and ors, the operands of the conditional operators must be Boolean values. So those Boolean values are either true or false, and the entire expression evaluates to either true or false. The equality operators. This is more tricky than one would think. You're trying to test things for equality. If you use the equality operators on objects, so equals, double equals if for comparing for equality, and exclamation point equals to compare for, well, not equal. If you use it on two objects, objects of any type, whether they're strings or some other kind of object, then the double equals is only true if both objects occupy the same space in memory. You can have two different variables holding the same memory address. They're really holding exactly the same object. They're pointed at the same location in memory. We call those aliases. You modify one, the other one gets modified as well. The double equals on objects is thought of as an alias check. It's a check to see whether or not those two variables are holding the same memory address. It's not checking to see whether or not those two objects are similar. It's checking to see whether they are at the same location in memory. On integers, it would work as expected. So it's pretty safe, and it does pretty much what you would expect if both values are integers. However, if you're testing for equality on doubles, okay, some variable of type double or a literal double, the double equals can't be trusted. It's because whenever you do double arithmetic, whether it be addition, subtraction, multiplication, or division, there is going to be some possibility of rounding error. And so even though you may have an expression that mathematically would evaluate to true if it's equal, the computer will sometimes return false if the values you're holding have been calculated using double arithmetic. So the bottom line here is if you're comparing two doubles for equality using the double equals, you cannot trust the results because of rounding error. If the values you have working with have decimal points, you want to stick with the relational operators, greater than, less than. If you find yourself using the double equals, you're probably doing something wrong when you're working with doubles. Integers, it's fine. With objects, you can run amok. And with doubles, you can run amok, so be careful with those. That's all I have to say about operators, types, and literals. Thank you.